Okay, 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 okay. Uh, Ayushi, screen is visible to you? Ayushi? Hello? Hello, Ayushi, can you hear me? Hello, hello, hello. Screen is visible? Hello, Nikhil? Ayushi, screen is visible?
Yes, sir, visible.
Okay, okay. So how many people are there? Let me check. Yeah, okay. So we are close to 7 people leaving me. Yeah, okay. Let's start. Okay, okay. So I live in suburb of Mumbai, and here every Friday there is a power trip. Fortunately, it happens in the morning, but evening it went for 5-10 minutes. Again, came back. So I'm sorry. So I was discussing about criteria for true experiments. Yes. Okay. Shall we begin? Shall we begin? Anybody say yes? Yes. Yes.
Yes, yes, yes.
Okay. Okay. Yeah. Yeah. Okay. So see, there are a lot many criteria for true experiments. Okay. So the first criteria is the manipulation of a variable by the researcher in order to determine a causal effect. Yeah, some variables has to be there which you need to manipulate it and check its causality. Second, all non-experimental variables should be held constant across condition and participants. This we discussed. Third, participants are randomly allocated to a condition. Very important, randomization. Even if you remember that lady testing T example, yes, there also there was a randomization, and there were 70 different uh, conditions were created by which the lady was tested whether she can sip the correct tea or not. Okay, or she can make it out whether she is sipping the right tea or not. Okay, so randomization is something which is very important in experiment. Okay, now again, control group, treatment group, we have talked about it, experimental group. Yeah, okay. Now again, something is very important, that how do you assign your participants to either of the two groups. Now again, in experiments, you need to have a control group and you need to have an experimental group, and interventions will be there in the experimental group. Whatever treatment that you want to assess or test, that will be brought into the experimental group. So there is one design which is known as between group design. So here it is characterized by having different participants in each experimental condition. So when I say between group designs, you divide your participants into two different groups, and participants in control group will be different, and participants in experimental group will be different, and there will be no what you call as इधर का उधर participant नहीं जाएगा, or whatever experimental conditions are there, people will be kept separate. So if you read that paper, transmission of aggression, so Bandura was very clear that certain students I'm going to expose them to aggression and they will be different, and certain students I'm going to expose them to mild form of aggression, and some people I'm not going to expose them to aggression. So he divided students in three different groups of 24 each, 24, 24, 24, and later on these students were not swapped at all. So सबका position fixed रहेगा. So that is known as between group design. It means every participant will be allocated to one group only, and there will be no scope that participants will be reversed. And next, there is within group designs. It means each participant takes part in all experiment condition. So in between group design, participants are fixed, their houses are fixed, and they will not be changed. But in within group design, participants can also come in control group. He can also be part of the experimental group later. So there will be switching of positions of participants from control group to experimental group. So within group design, there is no switching, but in within group design, participants will either be first they will taken to the control group, later on again they will be brought to the experimental group, and the impact will be tested. Yeah, okay. And lastly, this is match pair design. Match pair design means this happens is in paired t-test. Paired t-test. So let me give an example. What is matched pair design? So if I can use my, see what is match pair design. So between group design, and second is your within group design, and lastly is your match pair design. So what is match pair design? So let's say participants. Let's say there are participants 1, 2, 3, 4, and let's say this number goes up to, let's say, 30. So these participants before training their marks will be assessed, then they will be given training and again their marks will be measured. So the participants would remain the same. So participants in condition 1 and participant in condition 2, they will remain the same. So that is known as match pair design, and here you basically go for paired t-test. Yani before training you measure people's performance, after training you measure performance of the same people, and then you try to understand whether training has impacted or not. So that is basically a match pair design. So participants remain same in pre and post conditions. So that is a match pair design. Now it is up to you.
Professor Arun, the
Yeah,
participants would remain the same even in case of experimental and control group.
yeah,
But there you do the comparison between the delta, post minus pre. Are you saying in matched pair, basically you have only one group, there is no control group? Is that what you're
yeah,
trying to say?
exactly. Match pair design. There is no control group, sir. Yeah, you're correct. You're correct.
Okay, fine.
Yeah.
Thanks.
So that's why I gave the example. 30 participants before training, their performance will be assessed, and 30 participants after training, their performance will be assessed, and their performance will be compared. And if performance post training, if it improves, we will say yes, training has an impact or the intervention has
Yeah,
worked.
but in the absence of control group, it is difficult to claim high validity because it can be because of another variable which you haven't measured,
Yeah,
but
it
maybe
can happen.
existing.
It can happen, but there are certain designs where
Okay.
you have to take all the participants into consideration. Yes. Okay,
Okay.
it happens, and normally see even before, let's say I give an example. See, sometimes what happens that your participants are lesser in number, and you are trying to bring certain interventions which should work on that particular participant. Then in that case, training and control group design might not work. Yes, so that's why it is necessary to include all the participants at one go, plan some intervention, and later measure their performances. So that is the match pair design. So situation warrants. Situation warrants. Yeah. Okay. Uh, yes. Again, this paper I have shared with you. Please read this paper. Two-page paper published in 1982 by Professor Malte Anderson. Paper published in 1982. Most of us were not born in 1982, perhaps. Okay. So if you focus this paper, let's start with the observation, and this was there in the flyer. So I later I wondered that I'm proposing an workshop on experiment in social science research, and here I have given an example from birds or maybe from zoology perspective, so people might think that what kind of workshop is this. Okay. Okay. So Professor Malte Anderson, see the research questions. Observation: male widow birds have extremely long tails. So there is a bird which is known as male widow bird, and they have long tails. So the question comes to the mind of the researcher: why do males but not females have such long tails? Come on, if I ask you, or take example of peacock. Peacocks have long feathers and peahens don't have long feathers. Why is it so? Why is it so? Now I'll give an example that peacock have long feathers. Nature has made them attractive so that, and because if they have long feathers, that's why peahen are attracted towards them. That's the logic. So this long tail which widow bird have, it's nature designed so that the opposite gender gets attracted to them, or by this or by this long tail, the widow birds attract the opposite sex. This is how the logic is. So hypothesis: males have long tails because females prefer to mate with long tailed males. So this is how it is evolved. See, it is not in the hands of a female or of a male widow bird to increase the size of its tail. It's natural. It's natural. Yes. So the widow bird, male widow bird having long tail, it's a natural design. And now those widow birds who have long tail, they are going to attract more females. Now prediction. So if females prefer long tail males, then males with artificially lengthened tails will attract more mates. So what Professor Malte Anderson tested, read this paper. This paper is based on Charles Darwin theory that how species evolve and how how change happened in them, and so that there are certain natural or there are certain interventions which happen naturally. So Professor Malte Anderson says that if females are attracted by long feathers, then if I can artificially elongate the tail of female widow bird, then can it happen that because of artificial increase, more females can be attracted? So he wanted to test that. So he created conditions. See, he created 4 conditions. Now researchers, please understand there are 4 conditions. First condition, do not change the tail. See, first condition means select a widow bird having a long tail, natural. Second, cut the tail and reglue in place. Now, can you tell me what's the difference between first female widow bird, first male widow bird and second male widow bird to the left side of your screen? So first bird is a natural bird. You are not touching its feathers. Second bird, you are cutting and pasting it, but keeping the same. Why? Why? Hello. Third, see the third bird. Here you trim the tail of the third bird. The tail was long, but you trimmed it. And fourth, you you stick extra tail and make the length tall. Now, what is the hypothesis? The fourth male widow bird, it is going to attract more number of females. This is the prediction. See, what is the prediction? If you have, if a male widow bird has long tail, they are going to attract a lot of females. So now here you manipulated the tail. See, manipulation is happening in 3 birds. First bird, it is constant. Second bird, you are cutting its feather and resticking it. Now, why resticking it? See, because let's say.
So I think maybe if I'll take a shot at it. See, when you're in the experimental groups, when you're cutting it, it is no longer original.
Yeah.
So suppose the very act of cutting or sticking, suppose that has an impact on the other one in terms of being attracted. To eliminate that, if you are taking the second condition where you re-glue and still within the control groups you don't find a difference, then you can say that your condition of manipulating variable is successful.
To
Maybe.
a certain extent, Nikhil, to a certain extent. See, let's say if you cut the feather of a bird, yes. So let's say if you cut it, so now don't you think biologically you are affecting that particular bird? If you cut the feather, then it can so happen that the bird will be weaker, or some issue will happen to the bird. So that's why they try to match this bird 3 and bird 2. You cut it and see its strength of attracting females. You cut it and stick it and check its body position to attract females. So somehow you're bringing bird 2 and bird 3 on par. So that's the logic.
Good point.
Yeah, okay, because see, if you trim somebody's tail, then that automatically strength would be diminished, and because of diminished strength, he will be attracting lesser number of females. So you want to check whether trimming should not have an impact. See.
And basically, if trimming has an impact, then between 1 and 2, the both control groups, you will see a difference.
See, trimming should not have impact on health. See what I'm trying to say.
Exactly.
Of course, trimming will have impact. That female, as per your prediction, if the tail is small, less female will be attracted. So that is not the problem. That is what we are testing it. But trimming, does it affect the body structure or does it affect the health of the bird? So that's why you trim it, and here you trim it and add it, and then you bring both the bird on par. You don't see. In fact, bird 2 and bird 3 actually they are same health wise. Yes, both are trimmed bird. Bird second is also trimmed. That is artificial. You have added it. Bird 3 is trimmed, but there is no artificial. So bird 2 and bird 3 they are on the same wavelength. So you are creating homogeneity. And fourth bird, again you are sticking extra glue without trimming it. Already there was a feather. You are trimming it, and then you are comparing. So naturally, what is your expectation? The female which is trimmed, which is having lesser or lower feather, there less female would lay eggs, and where the widow bird has long tail, more number of females are going to lay eggs. So on the basis of the number of laid eggs, you are going to predict that yes, long tail attracts female. So here see all experimental designs has been created. So in this In this example, there are 4 experimental designs. Read this paper. This paper is given to you. Please read this paper. 2-page paper or 2-page paper. But you see, analytical part is very simple. They have simply compared. They simply use ANOVA and compared it. Yes, very simple. See, by the way, the statistics in experiments is damn simple. That's why I'm saying what goes before statistics is more important. Okay, so this is just a example that I've given, which will help you to understand that you have to create experimental conditions based on the participants, and somehow you have to create a homogeneity in all the experimental groups, and then try to bring the interventions. So that is essentially the idea. And if you focus on the conclusion, the hypothesis that female widow birds prefer to mate with long-tailed males is supported. So definitely it is supported, because wherever the long-tailed bird was there, the number of laid eggs was too much. So on the basis of the eggs, it was deduced that yes, long-tails widow birds, they are quite attractive, and they attract a lot of females. And the bird which feather was trimmed, it had very less number of eggs. So it was compared across groups.
Sir, in the same paper with the same control groups, I can I just change the hypothesis and say I've create a second paper out of it, because this experiment only here in the experiment we have considered only one hypothesis, that is the length of the tail.
Yeah.
Now, if I change the hypothesis that female birds they cannot make a difference between the real feathers or the artificial feathers.
Definitely that is what.
Only the length is what is impacted. So that would create a new paper altogether, right?
Create a new paper means they can't differentiate between an artificial feather or a natural feather. So you can definitely, but again you have to catch 4 birds, cut their trims and all, do these experiments.
Right.
Yeah. Okay. See,
Right.
empirical data, by the way, and this experiment was very difficult because you have to create lot of controls, and that's why you read this paper.
But sir, but just one thing, because we are discussing, if the hypothesis is whether they can differentiate or not, then we have to understand what is the measure of differentiation. That is not there in this study.
So
we'll have to think, how does that differentiation show up and how is that measured? I don't think we are measuring that, because here the measure is the number of people attracted.
Yeah, see, let's understand what I think Mansi asked that question. Or Mansi, am I correct? Yeah. Yeah. Okay.
Yes, sir.
Yeah. See, differentiation in the sense that again it's pretty settled. Now, naturally, if female widow birds, they are going towards a bird which is whose feather is elongated artificially, and that itself is an indication that female birds are not able to differentiate between an artificial feather and a natural feather. So differentiation, anyway, it will not be measured in a different way. It will be simply measured that how if bird 4 is able to attract more number of female, it means females are not able to differentiate. It's pretty logic. In fact, what Mansi will test it essentially the same idea. She will test the same idea, but she's slightly differentiating the hypothesis. That's it. But essentially the idea remains the same, that if they are more attracted, and but again some sort of variance is there. Okay, Nikhil, agreed or disagreed? Nothing. There is no wrong answer, please.
Yeah. No, I agree. I mean, I don't want to repeat. I got your point. All I'm saying is, here the entire, if you see the research question and the hypothesis, then the way we have predicted is, it is based on the number of mates attracted. I'm only saying that with the same measure, possibly the question of whether they are able to differentiate or not may not get answered. Because what differentiation means, whether I'm able to differentiate whether this is a real cut or not, whether that differentiation can be measured by the number of people mates attracted or not, we have to ask if that is the right valid measure from a validity perspective.
According to you,
yeah, Nikhil sir, you are correct. My point was just if I do
got
the same experiment, only length is predicting how many nests the bird will make. So I was making that point, that only length is predicting that.
Yeah, maybe you can have one
Yeah.
more measure and you can have same study
Yeah.
and publish two papers.
This
That
is
point I got.
Right.
yeah,
Right.
that is how
That's
Mansi
the
and
right point.
Nikhil, thank you for bringing this, and that is how you look at a problem. That is how you look at a problem,
Yeah.
and that is how you operationalize a measure. Again, if you're saying differentiation, again you have to be very clear about differentiation. But in my understanding, take birds and somehow add artificial feathers to it, and then see measurement would remain the same. But how do you measure differentiation? Uh, would slightly differ to a certain extent. Is correct. Yeah.
Yeah, but as I think again, sorry, I don't want to
Go ahead.
drag,
Go
but
ahead.
as I think again, maybe mate attraction may be a complex phenomenon, and if still it is happening, then that itself may be a good measure of differentiation.
Yeah. Yeah.
Yeah, measure of understanding whether it
Yeah.
is there.
If you
So
read
yeah,
this
maybe
paper,
it's true actually.
and the only criteria for attraction is the length of the feather. The length of the feather means larger the feather, larger the attraction would be. And this is what the idea is supported by this experimental condition. So read this paper. So this paper was discussed in Kolhapur University by elite statisticians who are consulting statisticians in 1982 paper. So that is how I got an idea why not take this paper as a base. And by the way, experiments are common across disciplines, and you try to measure something, or you try to test the causality or the hypothesis. Yeah. Okay. Yes. Now before proceeding with design of experiments, let's understand. By the way, let me see how many people are active now. What's so 9 people, 8 people are there. Yeah. Okay. 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 Let's focus on this. So again, an example which I borrowed from GP Box book. Now it says a footwear company intends to use. I've slightly modified this particular question from GP Box. If you read it, that's a different question. I made it different. So a footwear company instead intend to use either of two soles in manufacturing shoes in its factory. So there is a footwear company, and it wants to test two soles. Which one is better? That they will use it for manufacturing their shoes. So both the soles are made of different synthetic material and might differ in terms of quality. Now it can so happen that out of A and B, company wants to select that sole which is superior, which is better in quality, and which will last longer. Because if the shoes are of good quality, soles last longer, then they are going to attract more customers, and then they will sell more. The company intends to test both the soles and select the one that is better. So simply now company want to test, should I go for A or should I go for B? How should they go about it? Now here you have to design an experiment. Now see how design of experiment comes into picture. How will you design an experiment? Now this is a simple example. The similar design we'll have in social science. Again, this is from industrial example perspective. So now you have to design experiments. Now whenever you design experiments, now Nikhil's question will come into perspective. Nikhil has raised a lot of questions. What should be the sample size? Now you want to test two soles, sole A and sole B, and you want to determine which one is better. Either sole A is better or sole B is better, and this test of betterment should be measured. And then only after testing, if you're satisfied, okay, A is better, you go for A. If B is better, you go for B. You have to discard one. Now here you have to test both the shoes. Now how to test a shoe? Now you see car manufacturing company, they manufacture a car, and they allow that car to they they, they, they manually plan or they plan accident of that car, and they check whether all the uh, pillows are coming or not. क्या क्या रहता है उसके अंदर, I'm not well aware of it. But is the car safe? That is how they go and they collide the car with some other object. So what should be the sample size? Let's say if you want to test out of the
So,
two
but
sources.
before we go there, when you took car example, you very clearly defined for safety, you will collide and see. When you say which one is better, what is better here? Is it durability?
Durability.
Is it durability? Even durability. Okay.
Yeah, I should have been specific. It's about durability. The sole that lasts longer should be used. Okay. So now you have to test both the soles, A and B, and you have to actually test it. You have to make people wear these shoes and make them run for a certain number of days, and then test it. So what should be the sample size? Okay, anybody, what should be the sample size? You want to test sole A and sole B on durability measure. So what should be the sample size? 30, 40, 50, 60, 70? Okay.
one way to do it is if you have similar studies in the past and you know the effect size expected, small, medium,
Yeah.
or high,
Okay.
then if it's a high, if you expect that there will be a large difference, then a smaller sample size may be able to detect it. But if it is very little difference between the two, say one durability is 360 days, another is
On the
395
contrary,
days.
if the difference is
Hmm.
larger, I would require a larger sample size. And if the difference is smaller, I would require a smaller sample size. Okay, we'll come to it. Let's relax. Let's not get confused. So one example, what Nikhil is trying to say, see previous studies and see the effect size. Whether the effect size is small, medium or large. One argument, sample size. Okay. Now this sample size question will also perplex you in your research. Let's say you're planning a research for your students in classroom, or let's say you're doing a field-based research. Sample size issues, you have to address it. You have to address it. But please take it from me, all the papers that I'm reading across experiment research, their sample size is decided by the intuition of the researcher. The researcher or the experimenter, based on his intuition, and is trying to establish homogeneity between the two groups. And even if you read the classic papers that I've shared with you, none of the papers are talking about estimating sample size in experiments. Though there are standard techniques available, people talk about G-Power software where you can manipulate effect size, ANCOA, whatever test is there, you can fix it and you can estimate it. I have G-Power software in my machine. I do use it, but in experiments, I've hardly seen people using. There might be paper. I'm not saying there will be no paper, but most of the papers that I'm reading, there the sample size is determined by the intuition of the researcher, and he gives certain defensible logic in the design of experiment section. We'll see that. So what should be the sample size? Can you have a control and treatment group here? Let's say 50 students, they will wear sole A, 50 students, they will wear sole B, and see their performance over 1 month. But it can so happen somebody has taken a shoe kept in his house, not using only, or somebody has taken a shoe, he's playing very dangerous game that in 2 days only wear and tear will happen. Now, how will you control all those things? There are a lot many issues. Next, what are the interventions? Intervention means you have to put pressure on both the soles, and then you have to see which one is deteriorating faster, or which one is spoiled faster, or which one is getting or which one is dead, and which one is getting used to faster. So some interventions have to be planned. What will be the measurements? Now, how do you measure that, or how do you measure the wear and tear of the sole? That, and what will be the extent? Simply by looking at it, or by putting it under some machine. See, you have to measure. Let's say you take sole A and sole B. After 30 days, both the groups have used the sole. Now, by looking at that sole, you will say that it is spoiled to this extent, or you'll put it into some machine, and machine will give some number, and then you will test. Some measurements have to be there. By the way, there was one management guru, Peter Drucker. He said a very interesting thing. Anything that can be measured can be managed. I repeat once again. Anything that can be measured can be managed. So if you can measure how the wear and tear, or what is the extent of wear and tear, then you can manage it very easily. Anything that can be measured can be managed. What would be the hypothesis? What would be the hypothesis? Hypothesis is simply there is no difference. There is
No difference.
no difference, and alternative hypothesis will be A is better than B, or B is better than A. If it's one tail, you'll say A is better than B. If it is two tail, you'll say there is
A not equal to B.
Yeah, okay. So hypothesis, no difference and difference. Okay. What is the statistics that you'll be using it? See, before design of experiment, you should be clear with all these questions. Sample size, control and treatment group, interventions, measurements, hypothesis, statistics. So you should always ask these 6 set of questions to you before you design your experiment. Sample size, control and treatment group. But again, these are methods part. But before this method, you have to identify the factors. That which are the factors. You have to do a thorough literature review. That's why read paper again and again, read that paper and see. Let that paper tell a story. By the way, writing a research paper is actually telling a story. You tell a story, you weave a story. Introduction, you always make a promise. Literature review, you see what previous work has been done. Method, you try to be as scientific as possible. Results, it's based on your analysis of data. discussion, you compare your study with previous studies, conclusion, something different. What will it then here comes before that managerial implication, theoretical implication, all those things. Paper is pretty sorted, but what will you write? Again I'm saying, experiment research is just a method. Did qualitative study, quantitative study, all studies actually they contribute to some theory. Yes, writing is basically the same, but analysis might differ, or the approach, the method might differ. Now, what statistics? By the way, if you want to compare two souls, what could be the statistics? Anyone? What could be the statistics? Those who want to compare.
We can use t-test.
Very good. I think Sushil Kumar. Yes.
Yes, sir.
So you can use t-test.
Perhaps.
Which t-test?
Paired sample t-test.
Paired sample t-test में in both the group condition would same. The participant would be
Okay.
Okay. We'll come to it.
So,
of course, t-test is there. Independent sample t-test हो सकता है. Let's see. Now see what GP Box has suggested or designed for this particular experiment. A GP Box. Again, I'm saying this is not my example. I slightly paraphrased it and use my understanding in telling you a story. So in experimental design, see what GP Box did. The tests were run in pairs. Each boy wear a special pair of shoes. The sole of one shoe made with material A and the sole of other with material B. See here GP Box did not select control group and experimental group. Please remember, there are certain situations where you can't have experimental group or control group. Here GP Box, what he did, he made one boy wear two different shoes. In left leg, let's say material A, in right leg material B. So one boy is wearing a special shoe which is having two pairs of soles, which is having different soles. See what's the idea? See how genius the idea is. You see, all engineers, they think like me.
Sir, this is very, very interesting because it controls for different way in which you use the shoe.
Yeah.
If I were to use it differently, but I wanted to ask, in this, since both are the conditions you want to test, how about, I'm just asking, how about giving this person, say, 3 pairs of shoes? One is a normal sole, with some material C, a standard. One side, other is A. Then second pair has normal and B. And third is maybe A and B. Because here the A is getting compared to B directly. But you don't know whether A or B are actually, how do they compare as compared to a very standard thing which may be selling in the market at a given price.
Normal shoe here would not factor in, Nikhil, because
okay,
the choice is constrained in either of the two. Getting? So anyway, even if you take a normal shoe and even if it is spoiled too fast or not spoiled too fast, it doesn't make a difference because that is not the area of my interest. My issue was only to select one out of the best.
Okay, but which is the control group here then?
There is no such control group here.
Exactly.
There is no such control group, and by making one boy wear both the pair of both the soles, actually you are eliminating the difference within the unit. Okay, now let the person play cricket, let the person play football, let the person keep the shoe in the house. Both the shoes will be accustomed to similar wear and tear. Yeah. Okay. Next.
Yeah.
Now the decision whether the left or right sole was made with either A or B was determined with the flip of coin. Now remember, see, now we all wear shoes, we all wear footwear. Now just remember the footwear that you're using, which is the first one that gets spoiled. Now even I wear shoes. I have always noticed the shoe which I wear in my right leg, it spoils first. उसका वो टूट जाएगा या पड़ जाएगा. You see, because if you use, if there are people who are their right part is very active. So now I write with my right hand. So my right part of the body is more active. So definitely the right part, if I put A shoes which is of superior quality, वो जल्दी wear out हो जाएगा और B में ज़्यादा pressure नहीं देगा तो वो कम हो जाएगा. So there is variation in both the legs. So here what they did, they brought it randomization. That's why I said in criteria for a good experiment, you should randomize. take example of open book test. If you're planning open book test in a class of 60 students, randomize it. Divide the class into two groups. So 1, 3. So take an odd number and take an even number and divide it. You see, Arvind Kejriwal in Delhi, when there was a lot of pollutions, he brought this odd and even formula. Yes, and there are lot many papers written whether this worked or which helped to reduce population or not, pollution or not. But where there were extraneous variables, burning of lot of agricultural produce in Punjab, which was bringing it. So anyway, the impact would be very difficult to assess. So now randomization was brought as to which boy will wear which material into which leg. So there the coin was flipped. Third, in doing so, the pair of shoes were subjected to the same treatment, even if some boys scuffed their shoes more than others. So when you have randomization and when you have one person wear both the pair of shoes, both the soles, so there you are ensuring that both the pair of soles are given the same treatment. Okay. And randomized pair design. So such design is known as randomized pair design. So if you have such design and where you have randomly allocated both the pairs, so that randomized pair design is actually you are matching the pair and then you are creating randomness over there. So you are matching the pair. So and this is also known as blocking in experiments. You are blocking similar data. So that is the concept of blocking. So it's a randomized pair design.
Sir, which book gives many such design options? That same book gives?
Again, Design of Experiments by R.A. Fisher, 1935. Okay.
Okay.
R.A. Fisher's book. But see, Nikhil, to answer you, in social science, you have to be ingenious in randomization, but even a simple randomization would help you to address the uncontrolled variations. So that's why I'm saying whatever question that you raise, the only answer that I would give to you as well as to everyone to your question, and thanks for bringing that question forward, because it was really, I also thought of discussing that. I took that question and analyzed my view. Always follow standard papers, what they have done for randomization. Follow the standard paper, what they have done. Okay. So, but there are books and couple of books are written from social science angle also. Just read that book and then bring the randomization part. But again, I think the researcher's own intuition in randomization would help to do two better things. Randomization is you are not fixated about which person to include in which group. You are either flipping a coin or you are just tossing it out, or you're putting paper in the box and then selecting and segregating it. So it could be any technique of randomization. That's it. I think though there are scientific procedures, but even if you have a normal randomization, it would fairly work.
I just wanted to ask a quick question on randomization. Should I ask now or later?
Go ahead.
So suppose I want to give a intervention, say a meditation to a set of people. One is that I have one class, for example, and I divide that class. Half does meditation, half does not. Now let us assume for some reason I do not have additional infrastructure to separate out the half, and some problems like that. Then suppose I have 2-3 schools and very nearby schools, same board, same standard, same group, same education, everything. And then I randomly say, okay, class A, flip a coin. Class A will get meditation, B will not get, C will get, D will not get. I'm not doing it at individual student level. I'm rather doing it at the entire class level. Is that even randomization, or is it, say, pseudo randomization? I just invented, I don't know if that word exists.
First of all, this randomization will not work because there are certain concerns with it. Certain concerns is it that it is even if you plan such technique and if class 1 goes and tells to class B or class 2 that we are not part of it, automatically it will create a lot of misunderstanding in certain class which is not selected, and they might get offended. And normally when I was in Somaya, even you are in Somaya right now, I was a visiting faculty in KJ Somaya, particularly teaching OB and all, and Preeti Rawat madam. So even when we took students for IV, not with KJ Somaya, but I was with SK Somaya. So there was a lot of fight between students that who will sit into which bus, and their randomization did work. That some will sit here, some will sit there, But if you and people really take objections when certain bus was having AC and not AC, so might be this will not work. So in such cases, Nikhil, you should go for quasi experiments. You should go for quasi experiments. Okay.
Okay.
So when variables you can't control it, it's always advisable to go for a quasi experiment.
Or maybe randomly pick one entire school. If you have 7, 8 schools, one entire school getting, another not getting at all, so that there is no way that they
But
talk to each other.
again, there will be lot many other issues to answer.
Okay.
There will lot many issues will prop up. See to it that create homogeneity between the two groups, or select two schools which are in the close vicinity and people are from the same
Very
socio-economic
similar.
background. Then you can think of okay, and the school we introduced it, and the other school there was no unethical issues involved in not introducing in the other school, and people have done really well. So
And later on, as a wait list, we can give it to them once the experiment.
yeah, you can try. Yeah, okay.
Okay, thank
Let's
you.
go. Let's go ahead. By the way, hope this conversation is interesting and food for thought for others also. Yeah, okay. Let's proceed ahead. Let's proceed ahead. Okay. So this is the data analysis again borrowed from GEP box book. So boys shoes example, data on the wear of shoe soles made of two different materials A and material B. You see the wearing of you see the wearing is, don't you think it's similar? And see when you compare the difference is 0.41. Now the question is it statistically significant? Now difference between both the soles is 0.41, and if you look at this number 0.419, if you see that, is it statistically significant? The question is it statistically significant? In my understanding it will be not, but ज़्यादा कोई फर्क लग रहा नहीं है. Material है 13.2, 14.0. So here material B, it was in the right leg perhaps, because of which it might have bowed it might have bowed a lot. 8.2 left में, this is material A, material B. 10.9, 11. See, when you look at the data, you can't make any sense out of it. Then you should check the statistical significance of the difference. So GEP books just gives an examples and leaves it. It doesn't talk about too much. So here you need to analyze your data now. Yeah, okay. We will see in the data analysis part. Don't worry. The question is, or the idea is to show you how design takes place. Design is more ingenious. You have to be more creative, and you have to think in a very different and a unique way. That's essentially the idea. So tomorrow 2 case studies we have, and that will give you a fair idea as to how to bring the design and in a very genius way. Yeah, okay. Okay, now the question comes, design of experiments. By the way, design of experiments is very popular if you study, let's say, MSc in statistics. So MSc in statistics, or let's say you do MBA in business analytics. So there you come across design of experiments, but I'm not sure whether MBA in business analytics have this topic called design of experiments. But MSc in statistics, definitely in all universities across India, they have this design of experiments where people are learning statistics, design of experiments, DOE. Okay, and yeah. So what is DOE? Very important. It's a approach where you plan, where you conduct and analyze experiments. You plan. So in planning, it's very important that planning is basically a literature review stage. That you plan that which variables I'm going to include, what are the previous studies talking about these variables, what is known about this study, what is not known about it, or is it tested in a new context. So that's a planning. Then actually you go and conduct the experiments. You actually divide your groups, and then you bring the intervention, and then you later collect the data and analyze the experiments. So that is design of experiments. This idea was given by R.F. Fisher in 1935 in his book Design of Experiments. By the way, you should try to read books which are very, very classic, which are written by the original authors. Again, I would strongly suggest all of you. I'm sure most of you know this, but I've heard from many seasoned scholars from foreign universities. I regularly visit IIM Ahmedabad to update myself and to learn a lot. So I present papers in conferences, and I'm very choosy about which conference should I go. So there I talk to many people, and they are very dissatisfied with the state of research that is happening in India. So if people are publishing papers in A-star, A category paper, but who are the takers from their papers? Nothing wrong in publishing paper in those top-notch journals, but how is your paper contributing for the betterment of the society? Or how is it your paper helping practitioners to borrow certain stuff and use those interventions? So that itself is a very big question. That's why it is very important that every researcher should be more grounded and get involved into the problem and see what are the idiosyncrasies and what are the other issues which comes into picture. So there are many issues being raised, that you publish a paper, you get a cash, you become assistant to associate and associate to professor, but how is the society benefiting? And one way the society benefits, I can tell you, that all of you, whatever you learn, please share it. Whatever you learn, you share it. That is one way of giving back to the society. If you can learn something, publish your paper, and organize some conferences, organize some workshops, and be the speaker and disseminate that knowledge. Even if few people benefit, that is one contribution, that even a bit contribution you can make for the betterment of the society. So that is my thought process. That yeah, okay. So design of experiments, again, it aims to analyze the relationship between response variable and several factor variables. Now again, guys, students, just pay attention. Let me quickly go through it and come to the main argument that I'm talking about, and which will be helping everyone to understand research in a systematic way. So these 3 points are common sense. Just have a cursory look at it. These 3 points are common sense. We are talking about since 6 o'clock. 3 points. The experimenter intends to find out whether the change in the level of factors, and see this example, see this Excel, and here you have yield, here you have temperature, concentration, and catalyst. According to you, which one is the dependent variable and which one is the independent variable?
Catalyst may be the IV.
Okay,
It is there or not there.
okay,
And yield will be the DV.
okay. Okay, what about Sushil Kumar? What about Dr. Sunita? Dr. Sunita, are you there in class? Dr. Sunita? Hello? Hello?
Sir, temperature and concentration can be independent variables,
Okay, okay.
and yield can be dependent variable.
Yeah, okay. So fair
And
enough, fair enough. Let me go through this. Huh? Now focus. Yield, it's a metric variable, 60, 72, it's a random, see, some random yields in kgs, maybe in kgs or metric tons, whatever it may be. Temperature will be in degrees Celsius, 160, 180, 160, 180. So there are two levels. High is 180, low is 160. Concentration 20, low concentration 40, 20, 40, 20, 40. No third category. Catalyst 010101 or 000111. So here you have a case where dependent variable is entire metric, temperature, concentration, and catalyst. They are purely categoric. See, please. Dependent variable, metric, and all the IVs, temperature, concentration, catalyst, they are binary, or for that matter, they are categorical. Yes? Now just pay attention. Just pay attention. Just focus on this part. Yeah, okay. So let me draw a diagram. So what are you trying to understand? What are you trying to understand? Yes, let's say your yield is your dV, and what is your IV? Your first IV is temperature, which has two levels, which has only two levels, low and high. Second is your, let's say, second is your concentration. Yes, second is your concentration. So I'll write it here. Let me erase it. Let me use a different color. So this is your temperature. There are only two levels. Yes. Second is your concentration. And again, it has two levels. Concentration 2040. It is in percentage. So again, low and high. Yes. And let me slightly elongate this. Yes, and let's say this is the your third, and this is your catalyst. This is your catalyst. This is your catalyst. Again, it is low, high. Okay. So now uh, here, if you focus, so this is your response variable, or this is the variable of your interest. You want to understand the yield. You want to understand the yield. Yes. Okay. And these all three variables, these are your factors. Now these are your factors. Now please understand, now there is a formula that if you want to understand that what combination of the three independent variable cause the yield to increase. Now please bear this in mind. Now you want to understand that what combination of the three factors will cause the yield to increase. Should low temperature will go with high concentration, or with high catalyst will work, or high temperature with low concentration and low catalyst will work. So there are so many combinations. Now we normally come across this, that now if you want to understand the effect of the independent variable on the response variables, you need to perform certain experiments. Now how many experiments to perform? Now there is a term which is known as experimental run. There is a term which is known as experimental runs. So now you want to understand which combination of temperature, concentration and catalyst will give better yield. So how many experimental runs you need to perform? So there is a formula which is given by N is equal to 2K. So this N stands for number of experiments. N stands for number of experiments, and this small k, it stands for factors. It stands
Number
for
of factors.
factors. And this, or 2 to the power of k, this is read as 2 to the power of k. This is your levels. This is your levels. Now take this example. Now please focus on this formula. All researchers, please focus on this particular formula. Please focus on this particular formula. Now in this temperature, concentration, catalyst, yield case, yes, how many factors I have? How many factors I have? Factors is 2.
3.
So this 2 is constant. 2 is for 2 levels, and 2 by 3. There are 3 factors. So now 2 raised to the power of 3, 2 multiplied by 2 multiplied by 2, 3 times, this will give me 8. So now if I want to check that what combination of the independent variables will give me better yields, I need to perform 8 experiments, or 8 experimental runs. I need to perform 8 experimental runs. Please don't bother about it. Yes, because in social science, normally people don't go for these many experimental runs. In social science, you have either one factor experimental design, or 2 factor experimental design, because you don't want to increase the complexity. Yes, okay. Now when you have 3 factors, so there will be 2 interactions and there will be 3 interactions. Complexity is going to increase. If you increase the independent variable, the complexity is going to increase. The interaction term will set in. Now just pay attention to this particular. Hope this slide is okay. And now pay attention. So factorial design. What is a factorial design? So there is a formula, N is equal to 2K, where N stands for number of experiment runs, or 2K, or 2 levels and 3 factors. So let's say if there are 3 levels, so 3K. Okay. So 2 is number of levels, and here if you focus, all your independent variables have 2 levels. All the independent variables have 2 levels, and they are basically categorical. Rather, they are binary. Nobody has 3 levels. Please bear this in mind. Okay. And let's check. So what's the number of factors? So let's say if you have 2 factors, how many minimum experiment runs you have to perform? 4. If you have 3 factors, how many experimental run you have to perform? A. Simply substitute 2 upon number of factors. K is number of factors. So 2 by 2, or 2 raised to the power of 3, 2 raised to the power of 4, So if 2 is 2 raised to the power of 4 means 2 multiplied by 2 multiplied by 2 multiplied by 2 will give some number. And lastly,
16.
if there are number of factors 8, if there are 8 factors, so 2 raised to the power of 8, you should go for 256 runs, which is very, very complicated. Getting? So that's why experimental designs in industrial setting and experimental designs in social science settings, here slightly there is a difference as far as experimental runs are concerned. Now in social science you have minimum number of, you try to have a minimum number of runs, because more experimental runs will cost you more money, more time and more complications. Because 2 by 2 factor, there is also a treatment effect, because there is an interaction, because when you are simultaneously regressing yield on 3 independent variables, so independent variables are going to interact among themselves, so there will be two-way interaction and there will be a three-way interaction, and which is going to complicate the matters. But yes, you can go for model comparison. Day after tomorrow we'll see how to run all these experimental runs using the same data, and to determine the best model or best combination of all the 3 independent variables which impacts your dependent variable, that is your yield. Okay, so just hold on. When we'll be analyze the data, we'll be focusing on all such stuffs. Yeah, okay. So what is it? So now let's imagine you have 3 variables, A, B and C. Let's say you have 3 variables, A, B and C. These are your factors. And how many runs you need to perform? Let's say all your factors have 2 levels. So if all your factors have 2 levels, the formula is 2k. So 3 factors. So 2 into 2 into 3, that it means total 8 runs you have to perform. So this is your, if you focus here, A is your factor 1. It has 2 levels, minus, plus, minus, plus, minus, plus, minus, plus. B you will go for minus, minus, plus, plus. See how it is written. First minus, plus. First see the column A. Minus, plus, alternate. Column B. 2 minus, 2 plus, 2 minus, 2 plus. Column 3. 4 minus, 4 plus. It means every row, 1, 2, 3, 4. This is a row. Every row is a combination. Every row is a combination of factors with different levels. And when you go for factorial design, actually you reduce the number of runs. So reducing the number of runs is saving your time, money and complications. So normally in GEP box books, if you read the chapter, you will find that this is how the cube, you create a cube shape and you decide that how many experimental runs needs to be performed. And here you can see this diagram where C and A arrows, they are dotted. Dotted means they are not, they are inert, they are variables, but they are inert. They are not causing the yield to increase. Yield is increasing because of this particular variable P. Yes. So this is one example. Now, by the way,
So when you say 8 experimental runs, are you therefore saying that in one experimental run you fix say minus minus minus, and then you take a lot of different observations?
yeah, I can see eight experimental run. To answer you, Nikhil,
What happens in each run, if you can just
what happens
elaborate?
in different combinations? Now you need to repeat this certain number of times. So minimum 8 run will help you to address all the factors. Yes, okay, and you can repeat it 2 times, 3 times, and you can see that what's the impact. But at least this experimental run suggests that at least 8 runs needs to be performed in order to check all possible combinations. That is the minimum run that you need to perform. But again, this example is more from industrial setting example. This might not be related to social science. This is just to make you understand that what is the idea of experimental runs. So if you have let's say 2 factors with 2 levels, so minimum 4 runs you need to perform. Minimum 4 runs you need to perform. Yes, that is essentially the idea. So we'll be seeing it when we'll be analyzing the paper in case studies. We'll see we'll understand the concept of the experimental runs. Okay, so let's focus on this particular part. Yeah, okay. So now, which test statistics do you suggest if you want to measure that how yield is better, or by which combination, by which ideal combination of the three independent variables the yield is better? What statistics do you suggest? Come on. Yes. Hello. Hello. Yes. Which statistics? Come on. By the way,
So this
So
will
we
be
can
ANOVA, but it will be factorial design, 2 cross 2 cross 2.
okay. So discovery of statistics using SPSS. This is given by Professor Andy Field. Classic book, seminal book, masterpiece book, like GB box. Okay. So there, let me give you a food for thought. You go for t-test. Yeah. Then ANOVA is nothing but an extension of t-test. UNCOVA is nothing but you have a covariate, and then you have something known as regression. And if you read this book, Discovering Statistics Using SPSS by Professor Andy Field, he says all these statistics are one. Actually, the idea is same. The idea is
so we can
Yeah, after
we
all, they're all
perform
general linear model, no?
the general linear model, the test of means. Mean is at the center. Yes, okay. Now just focus. Here you have your IVs and your DV. Your IV is temperature, concentration, and catalyst. Yes, okay. And your DV is only yield. Yes, okay. So you can definitely go for ANOVA, no problem with it. You can go for UNCOVA also, you can have a covariate other things. But regression will help you to put things into better way. Now, please remember that regression is a parametric test. Regression is a parametric test. Now, what's the difference between a parametric test and a non-parametric test? Anyone? What's the difference between a parametric test and non-parametric test? Now, you will say that parametric test comes with assumptions. They have riders. They have assumptions, and if those assumptions are fulfilled, then only you can go for parametric test. And non-parametric tests, they are assumption free. They don't carry any assumption. This is what your argument is. But let me tell you one catch here. Why parametric tests are more important and why it is used so often. Yes, in parametric test, they are very robust and they are rigorous. One argument. Second, in parametric test, you collect data from sample, but you comment about the population. So there is an element of generalizability in parametric test. In parametric test, you collect data from the sample, but you comment about the population. So parametric test is more generalizable. In non-parametric test, you collect data from the sample and you comment about the sample only. You can't use sample information to comment about the population. That's the difference. That's why people are mad behind parametric test. People are mad behind parametric test. Why? Because there is an element of generalizability. You collect data from sample and you comment about the population. That is a decent. But in non-parametric test, you are collecting data from the sample, but technically you are not allowed to comment on the population. You will comment on that sample only from the data. That's the difference. That's why non-parametric tests are not that popular, because here there is no element of generalizability. In parametric tests, there is an element of generalizability. Now, coming to social science researchers, lot of social science researchers use statistics. Lot of social science researchers use statistics. By the way, if you talk to some consulting statistician who have done PhD in statistics, or for that matter MSc in statistics, they don't take social science researchers seriously. You know why? Because social science researchers, they don't test assumptions. Now social science researchers, they work with Likert scale, self-reported measures, Likert scale, and your Likert scale data will always be skewed. The normality assumptions will always be violated. You can't have a normal distribution in your Likert scale data, but you don't test assumptions. And social science researchers, they use convenience sampling. So when you use a convenience sampling, don't you think that there will be a sampling bias? There will always be a sampling bias. There will always be a sampling bias if you use convenience sampling. Then what authority you have to use parametric test for a sample which is biased? And how can you say that if this sample behave this way, the entire population would behave this way? That's why hardcore statistician, they never take management researchers seriously, because management is jugaad. Sorry, on a lighter note, please don't take me every word of my in literal terms, but this is what I've heard from some of the finest of the statisticians. Yes, okay. So now regression is a very robust test, and people use it so casually. You see best of the reportings in finest of the papers. People are silent about assumptions of all the parametric tests. People simply run a regression and they say, okay, this is the
All those 5 assumptions are not tested.
yeah, whatever. So assumptions are not tested, and they say, okay, I have a decent model fit. This is my F stats. These are my independent variables. They are significant, non-significant. They report it and they are silent. But you see, of late there is a trend. The people are using SEM like anything. SEM, and now PLS SEM is gained popularity. Yes, people are using all the SEMs. Yeah, and they have multiple papers using SEM, PLS, SEM, all those papers. But again, even in SEM, there is something known as multivariate normality assumptions. People don't test it. PLS SEM is a non-parametric approach to SEM. It's very liberal. No assumptions. But there are assumptions which sets in after your structural model testing. That again, that is not reported. People are silent. So people, as far as usage of statistic is concerned, people cherry pick. People cherry pick and they report what they want to report. They are silent what they don't want to report. But my humble request to all of you would be is that check for all the assumptions and report. Because if assumptions are belied, then your parameters won't be taken, or your sample statistics will not justify the population parameter. So that is always the concern that you should be mindful. Always check for assumptions. That is one catch I would like to give. Yes, okay. Now coming to this temperature, and the best statistic would be regression. So regression, why is my independent variable? So let's say y is yield. Okay, so yield depends upon what? Yield depends upon some coefficients which is constant, that even if there is no independent variable, there will be yield. Yes, so beta naught, it is constant, plus then my beta 1 will be temperature, plus my, let me erase this part slightly. So we'll cover all the statistics in detail, don't worry. R is pretty learnable. Then my beta 2 is what? My beta 2 is concentration, plus my beta 3 is my catalyst, plus my, there will be interaction terms. So there is a two-way interaction. So two-way interaction, let's call it beta 4, and let's say dot two-way interaction, and then there will be a three-way interaction, so beta 5 dot 3, plus there will be some error terms. There will be some error term, or this is your error of regression, or error in y, or we can put it error in prediction of y. So this many combination you have to try in your statistics. Yes. So what is this beta naught? Beta naught means even if these variables are not present, there will be some yield. Yes, there will be some yield. And what is beta 1 temperature 1? Other things remaining constant. Other things remaining constant, let's say beta 2, beta 3, beta 4. Yes, 1 unit change in temp or 1 unit change in 1 unit change in temperature will cause this many unit change in yield. Relax even if you don't understand. So beta 1 temperature says that 1 unit change in temperature will cause certain unit change in y. Other things remaining constant. And regression has certain assumptions that normality of the residuals, heteroscedasticity, homoscedasticity, many are there. I'm not remembering it. Please don't ask me questions on that. But it's there. So there are some assumptions, and linearity assumption is there. Normality of residuals assumption is there. Homoscedasticity is there. Heteroscedasticity is there. No multicollinearity should be there between the independent variables. There should not be endogeneity. Autocorrelation should not be there. In fact, there are many. There are 7 to 8 assumptions. In regression, there are around 7 to 8 assumptions. And there is a book by Montgomery. Please read this book, and again you will find a chapter on design of experiments. So if somebody can find this book on Montgomery, very old book, please upload in the book section. So the drive section is open. You can display citizenship behavior. You can help this workshop by, if you have some materials or reading materials on experiments, please upload it. It's open. In all my workshops, when I'm very open in the sense that I don't say that I know everything under the sky, but definitely I will ignite certain curiosity in the participants, and you will get your money's worth. I don't know what made you register for this workshop. There are no official websites and no credible source. You simply scanned and paid and trusted it, and some person without hair came and started teaching you. So maybe so that tells a lot about you. But in all my workshops, I tell all my participants, and it's simply because of trust that I built with people over the period of time. And in this workshop, I have fostered some of the finest relationship with best of the people. They are connected with me since a very long period of time, and we all enrich each other. So that's why Google Drive is open, and whatever reading material stuff that you have, you can upload it there from your side. You're from most of you are from prestigious institutions, IIT Roorkee or Delhi University, KJ Somayas. These are some of the good institutes. So whatever downloadable material you have, upload in the drive so that everybody benefits from it. Okay, that is essentially the idea. Okay.
Sir, I missed one thing. What was beta 4 here? Beta 1, 2, 3, I understood. What is beta 4
Beta
and
4
beta
is the
5?
interaction term. So there is a two-way interaction.
Interaction. Yeah. Between temperature,
So there is a two-way
concentration.
interaction and there is a three-way interaction. So these two will interact.
Yeah.
So these two will interact, and there will be interaction between these two. Okay, then there will be a three-way interaction. So these are interaction terms. Okay. Okay, let me see how many slides are there. So what is quasi experiments? Come on, what are quasi experiments? Yes, what are quasi experiments? Okay, so quasi experiments, by the way, all my friends, just a humble request to all of you that you all should definitely read this paper and plan some experiments in your classrooms with students. And this is the paper which is a quasi experiment. Now I have written one line that quasi experiments will talk about it. So this paper talks about developing psychological capital and emotional intelligence in higher education, a field experiment with economics and management students. So I think Nikhil was talking about, can I have a group where somebody will be given yoga and somebody will not be given yoga in a different place? That's perfectly feasible, but in the sense that inculcate that in a syllabus. Let's say in one course you have an official syllabus of yoga, in another course there is no syllabus, then there won't be a discrimination. So actually this is a classic paper, you should read it. I don't know what's the category of this paper, whether A or B, but it's a finest paper, wonderful paper. When I read it, I enjoyed it like anything. क्या paper है ये? और ये तो classroom में हो सकता है, ये experiment classroom में हो सकता है. So wonderful paper. This is a quasi experiment. Read this paper. Actually, I discovered this paper very late, and I discovered this paper earlier, so I would have taken this as a case study in order to make you understand how experiments can be planned in a classroom setting. Wonderful paper, quasi experiment, and the researcher has made no attempt to control the treatment variable particularly, or the independent variable. Wonderful experiment. Read this paper. It's about quasi experiment. So let's talk.
So there is no randomization, is it? Is not done
Sometimes
randomization.
randomization is in the design itself. Let's take example of a program in MBA school. So there are a general MBA program, there is a marketing program, there is a HR program, there is an analytics program, there is a sports management program. So people are coming randomly and taking admission in those courses. Automatically randomization is there. Getting? Sometimes randomization is automatic. So that is a quasi experiment. No, quasi experiments actually you're not taking randomization, or for that matter you're not controlling the variable. That is a quasi experiment. But randomization should be there. But sometimes in design itself is randomization is there. So quasi experiments, it is not possible to manipulate the variable of interest. You can't manipulate the variable. Sometimes it happens. There will be situation where you can't manipulate. Like you can't manipulate uh, uh, a group where you tell certain people to smoke and certain people not to smoke, and then check the effect of smoking on cancer. Yes, okay, but that's why I'm saying read this book, Naked Statistics by Charles Whelan. There you will understand that which are the instances where you need to design experiments and which are the instances where design of experiment will not work. Okay, so not in every setting design of experiment will work. There are like cross-sectional research or longitudinal research will work, design will not work. Yeah. So these experiments are not as highly controlled as a true experiment. So there the element of control is not that high. So that's why they are not pure experiments. Quasi means semi experiments or somewhat experiments. So these experiment studies a given phenomena with lack of experimental control. Same argument. And researchers in quasi experiment must be careful not to overstate the findings. So you can't have a generalized findings. Okay, I'll tell you one interesting fact. So few years back, let me show you one book. So this is one book. This book is by Stories of Marketing in India, and it is written by Professor Anand Karandikar. Now he's a IIM Calcutta graduate, Professor Anand Karandikar, and he talks about a very unique set of experiments in his book. So I flipped through pages and then I got a very interesting idea. He talks about, now he's a PhD in management from Pune University, not that Pune University is a state university, and he talks about mystery customer. So now he wants to understand whether dealers are recommending your product or not, or how dealers are talking about your product. See, normally when you go to buy something, so dealers will definitely favor certain product over other products. So now a company wanted dealers to be committed to their product so that company achieves sales. So he sends mystery customer. He himself becomes a mystery customer and goes to the dealer and talks, yeah, I want to buy a television, which television you recommend? And the dealer was recommending the competitor's product. So this man he's a consultant, he gets angry. So he comes and reports the dealers who are stocking your product, they are not talking high about your product, because of which your product is not getting sales, not getting sold. So that then they come out with a model like how to bring the dealers or how to ensure that the dealers are very serious about your product and they definitely talk good about your product, so that ultimately they push up the sales. So these are some of the quasi experiments that you are not informing the dealer, you simply go as a mystery customer and you record the observations and then you create an experiment condition. So this is a wonderful book. Again, I don't know whether this book is there in the Amazon or not, but do order for your library, Stories of Marketing in India, and just read through the pages. You'll get a decent understanding from this good book. I liked it, very grounded book, not very popular author, but the book is decent and he's a consultant and doing pretty well. I met him recently, doing excellent. So yeah, now let's talk about the ethics in experiments. So what are the ethical issues in experiments? So what ethics should be there in experiment? So now immediately after World War II, you see, I'll tell you one interesting fact. My research is all into healthcare and particularly pharmacovigilance. And so I happened to study some of my sample by observing them when I was doing my thesis. So in when World War II started, the Nazis were very brutal. So they used to take this uh, Jews into concentration camp, and they used to torture them like anything, inhuman conditions. So there, these people also, there were not many doctors who used to perform experiments on these Jews. The Jews have suffered a lot, I must tell you, and that's why they're a very adventurous lot, and they are fighting terrorism in so many places. Again, it's not a question between. It's a recorded lecture. It will be going on YouTube. It's not a question of two religion per se, but Jews were really prosecuted like inhumanly in Germany under Nazis. They suffered a lot, and their experiments were performed on them without informing them, and many people died in those experiments by these Nazi scientists. And so immediately after World War II got over, so this Nuremberg Code came into existence, and it talks about some of the ethical issues that you need to consider whenever you design experiments. Now, other than Nuremberg Code, there are certain Universal Declaration of Human Rights. Then there are research ethics as far as American Psychological Association is concerned. So there are so many ethical issues in experimentations. But let's say you are conducting experiment in social science. The first litmus test is to seek permission from the head of the institution. Let's say you are conducting experiments. It is always advisable to inform. Let's say you are working in some college or university or maybe some business school. Inform the institute head or the director or the principal that you are conducting experiments and this purely for academic purpose, and nobody will be harmed and nobody will be subjected to unethical treatment. That is one thing that you can follow. Simple as that. And apart from that, there are certain other Nuremberg Code, and it's always advisable to inform your participants also that some study is being done. But again, you have to be cautious, because if you inform them study is being done, they will get alerted, and that might act as an extraneous variable, or that might act as a confounding variable. So you need to be slightly smart whether to go for full reporting or not. That you should be cautious. So these are some of the codes which is adapted from this CARTS paper 1972. You can simply have a cursory look. Again, I need not read it because most of you are matured professors and research scholars from eminent institutions. I need not talk much in detail. These are something which is very, very self-explanatory. Very important point which I see here is the human subject should always be at liberty to end the experiment. And by the way, also you should focus on this experiment, the sex raft experiment, and how the experimenter, in order to achieve its objective, in order to study violence, he really tortured his subjects. And this experiment happened in a rowing ship in an open sea, and the experimenter really created certain situations for the subjects where subjects were harassed. So that should not be done. That is unethical. That is criticized. So it's a famous sex raft experiment. You should definitely focus on it. So there are certain ethical issues in experiment that you should be mindful of. But again, whichever paper or whichever journal you are targeting, read what ethical guidelines they have to carry out the experiments, and what reporting issues needs to be done. You need to be mindful of that, whichever journal you are targeting. And apart from that, there are standard Universal Declaration of Human Rights, ethics, and Nuremberg Code, and so many other ethics codes are there that you need to be mindful of. Okay, and tomorrow we'll start with this experiment case study. So let me stop the presentation and take a couple of questions from you. So come on, the floor is open, and officially whatever I had to share for the first day, I'm done with it. And you can ask me any questions or any takeaways or any issues or some new points that you have. Please, I'm not talking about the feedback of the session. Don't give me feedback. That is restricted to the last day. Talk about issues and concerns, or maybe your takeaway, or what you can share about it. Come on, the floor is open. Yes. Okay. Hello. How many are there? Okay. Any queries from whatever was discussed?
Sir, just I have a query. Since I am very new to the field of experimental research, this was in fact my first session on the same, but I've been very keen on doing it. The bend of mind is that the time spent on experimental research depends exactly on how much time the researcher spends. and I think I can write papers faster if I conduct an experimental research. Is that school of thought correct?
So how much time the experimental spent on what? On collecting the data?
If I plan it, so normally when I do a research, maximum time is spent on data collection.
Yeah.
If I do it through Google Forms, or even I collect it through personally or interviews, if I do a survey, a lot of time is spent on data collection. But since I'm already a faculty, so experimental research and in the field of education, if I might pursue, I might save a lot of time in data collection.
Very good.
Am I
Pertinent
correct?
point. Dr. Mansi, you're 100% correct. In fact, experimental research will not cost you much time. In fact, within a week you can collect data if your setting is correct.
Right.
Getting in
Sir,
cross-sectional
and
research, you take 6 months, 7 months, even a year to collect data.
right, right,
Yeah. Good.
right.
Fair enough. Valid
Sir,
statement.
one request I have, since you are quite fluent in this kind of research, can you suggest some journals and put the names in the drive so that
Okay.
it is helpful for me, because
Okay. So
looking into the distance, it's a new field, so I'm not aware of many journals that
yeah. Okay.
would accept my research.
So first is this is a Journal of Behavior and Experimental Economics. It accepts only experimental research. Exclusive journal. Journal of
Okay.
Behavior and Experimental Economics. Again, I said all A star paper, A category paper, B category paper. Yes, they in between here and there they accept experimental research. By the way, there is one
All
journal,
right.
Basic and Applied Social Psychology. Basic. You're from which field, by the way?
Management, sir.
Then marketing, finance, HR.
Marketing. My field of specialization is marketing.
Marketing. So there are a lot many research in marketing. Now you can do one thing, Mansi. Just type ABDZ, ABDZ, ABDZ list. Just download this ABDZ list.
Okay.
Yes. And you can simply download this journal. You'll get an Excel sheet. See, this is
Right.
downloaded Excel sheet, and just see all A category and B category paper. Most of the papers accept experimental research. Experimental research is very popular. The moment you do experiment, no, people's curiosity get ignited, because in experiment you are checking an intervention. I'll tell you
Right.
once one interesting fact. You can see that in my house there is one patch. Can you see this?
Yeah.
I was very
Right.
worried.
I can.
So I was very worried about, like, somebody died in my family. I have to shave my hair, and there is a patch. So this patch is because of an experiment. So I wanted to hang a board here. You can see this. And I was not sure. I just hung the board. Automatically color came out, and I could not hang the board. So knowingly, unknowingly,
Okay.
Dr. Mansi, we do a lot of experiments in real life.
Right.
Yes, unknowingly we do. But here, when you design experiments, knowingly you have to do everything. Getting?
True.
So there are many papers.
Right,
Marketing,
sir.
in fact, I'll tell you, marketing. Focus on this paper, Journal of Consumer Research. It's A-star paper. But again, A-star paper is very difficult to crack unless you have some good people.
Yeah, that is the next point I was going to make.
No,
So since a beginner, I am not targeting A star,
no.
not even E. Even C would be fine for the first paper.
So you do one thing. First, initially, keep a lower benchmark. Target B or target C, and
Right.
most of the marketing papers, most of the marketing journals, identify 10-20 journals where marketing belongs to marketing discipline, and send your paper if it's a genuine experimental research, and if you have added the necessary rigor, definitely all these journals are going to accept it, because experimental
Right.
research have that aura, because the moment you do experiment, people are ready to take it, because here actually you are understanding the cause and effect relationship, which is not there in a cross-sectional study. So longitudinal study, time series study, and experimental study, they have that aura, provided it is written well, and they get immediately accepted.
Right.
And most
Sir,
of
what is the chance of papers in education research being published in experimental journals?
definitely publish. See the paper. This paper, the paper that I shared with you just now. This developing. It's an education journal, International Journal of Management Education. I think it's B category or A category, but wonderful paper, nicely written.
Okay.
So definitely education also, there are many publications which accept it. So download that
Right,
ABDZ
sir.
list paper, you get an Excel sheet, and you can just scan it, identify papers which are from education. Definitely not many people accept it.
Right, sir. Thank you so much.
Okay,
It was a great session. Thank you so
okay,
much.
okay. Anybody else?
Sir, I have a few questions. So, when you say longitudinal and you say experimental,
Huh.
if I do an experimental study pre, post, and say a follow up
Huh.
after, say, 6 months, 1 year, or
Yeah,
2 years, isn't that a longitudinal study?
see, longitudinal study, please understand that let's not see experimental and longitudinal study as one. Both are different. Longitudinal study is that you do a two-wave study or a three-wave study, in the sense that you collect data today, then you wait for 5 months or 6 months or 3 months, and then you collect the data. Yes, so that is a longitudinal study. And then again, in longitudinal study you can check for causality, because you are checking the same thing over the period of time. So normally there are a lot. You read this journal of organizational behavior. Again, it's an A category paper. You'll find that the people go for two wave studies, wave one, wave two. So in first study they collect this data, in the second wave they collect this data. So that is a longitudinal study.
No, so my question is, I get your wave thing, but are you manipulating a variable or not in the
Longitudinal
longitudinal
study,
study?
answer is no. In longitudinal study, no, we are not manipulating it. Manipulation happens only in experiments.
So basically, are you therefore saying that when you do cross sectional, it is at a point in time you're taking
Yes.
a cut? Here you are having waves, but then what is the studies called where you have pre, post based on manipulation and then follow up, and then a follow up after very long where you want to see whether the effect is sustained or not?
So
So that's an
again,
experimental study, right?
again, see, if that is so, the author would have written it, whether he is seeing that as a longitudinal or whether he is seeing as an experiment. So again, you should follow the tail of that paper, what the author is talking about. If see, people are very explicit and categorical about the method that they follow. So definitely it can happen that pre and post can happen at two different point in time, or that there could be a big gap also. So follow that paper, see how the authors have articulated the methodology section, and then make a point that yeah, okay, this is experimental or this is longitudinal. But longitudinal experimental study, these are two separate studies. These are two separate studies. Let's not mix it.
Got it.
Okay. So I'll give an example just to answer Nikhil. So there is one marshmallow theory. So marshmallow theory, I'll give an example. So this theory is about that a professor wanted to understand the impact of delayed gratification on success of students. So you want to study the impact of delayed gratification. So what the teacher does? Teacher distributes chocolates to students and tells them, if you wait for 15 minutes and don't eat this chocolate, after 15 minutes I will give you one more chocolate. So he goes out of the class. This is an experiment. Huh? The teacher goes out of the class. So now not many students eat the chocolates. Few students didn't eat the chocolate. So those students who didn't eat the chocolate, teacher rewards them, gives them extra chocolate, and those who ate them, they were given nothing. And then teacher tracks the performance of these students in a longitudinal study. Means people who didn't eat the chocolate and got the extra chocolate, teacher tracked their performance in 10 years and 15 years, and the teacher found that people who were able to delay their gratification in their formative years, they were more successful in life. So here you can see what you are trying to ask, Nikhil. There is one what you call as an experimental design in the first stage and longitudinal design in the second stage, to answer you.
Oh, very interesting. Okay.
Yeah. Okay.
Yeah. So you're not seeing whether there is a sustenance here, unlike an experimental which continues, but you did an experiment, tested your hypothesis, got to know who have that propensity, and then you tracked those people for a long
Yeah,
time,
yeah, yeah. So it's a mix
like
of
that Harvard study on adult
yeah,
development, and then
yeah.
it's a mix of
Mix,
experimental
mix,
and
mix,
longitudinal.
mix, mix. Yeah. Hope it addressed your question.
Yes.
Okay. Anybody else? Sushil Kumar, Ayushi, Hardeep. Hardeep, you're from where, by the way? Hardeep.
Hello, sir. Am I
Hardeep.
audible?
Yes, you're audible. Yeah.
Sir, I'm from Jammu University and I'm a research scholar and
Okay.
I'm pursuing PhD. Sir, I have a little question.
Yeah.
Sir, in the last slide, the Nuremberg Code slide, I saw one thing that experiments should only be conducted by qualified persons. And since I'm pursuing PhD, I've never done this before.
Okay.
Sir, Any suggestions?
So the scientist should be prepared to terminate any experiment, which one last
No,
point
no, eighth point.
should only be conducted by qualified persons. So this is
Yes, sir.
Nuremberg Code. Most of the points are people from medical disciplines. So in medical
Oh, okay.
disciplines, you
In
should
that.
definitely have a trained person. Yeah. Okay.
Okay. Yes, yes, yes. Okay. Sir,
Sir,
just
I
one more
know.
question.
Go ahead, Hardeep.
Sir, can we, like, I was thinking, can we use the AI for designing of an experiment?
Definitely.
Like,
What is
I give.
definitely use Copilot, use Chat GPT, use Gemini. Plan the experiment. It will give you some idea. By the
So,
way,
so won't that be illegal or something like that? Just
no.
wanted to clarify.
See, simply don't plagiarize it. There is
Yeah.
one site called Data Tab. Data
Mm-hmm.
Tab. This help you to design all these factorial studies and all. It's a wonderful year. It's a Data Tab.
Okay.
Datatab.net. Again, this will help
Mm-hmm.
you in analysis and planning your experiments. So there is a DOE, Design of Experiments calculator. So
Okay. Okay.
here you can full factorial. There are so many factors. You see, this is design of experiments very complicated, by the way. I've touched only factorial
Yes, sir.
design per se. I didn't touch all this fractional plugging in the
Mm.
box and all this. This is not my area. But again, this is not used in social science. It's very big, huh? In fact,
Yeah.
design of experiment is very big per se. So
Mm.
but data analysis, this is good, and designing the number of run this site is very good. See, first of all, there is nothing harm in using AI, Hardeep ji. You can definitely use
Yes,
AI,
sir.
nothing wrong with it, but simply don't now see, journals are also very clever. Now a couple of my papers are rejected. You will see, I submitted my paper to International Journal of Organizational Analysis, cross-sectional study,
Okay.
and they rejected within the second day itself. So I thought other papers, this was the fifth rejection. I said other paper took time, other journals took time to reject, and International Journal of Organizational Analysis, which is Q1 and AVDZP
Mm-hmm.
category, why did it reject so early? So I used this quilt board to paraphrase one of the uh, abstracts. I thought maybe using quilt board to paraphrase also maybe a crime. That's why they might have certain AI inbuilt into their process, which might have caused me to.
Mm.
So that is one concern. See, don't nothing wrong in using AI, but writing should be your own part.
Yeah, yeah.
Yeah, you can.
I'll only be using AI in designing of the images or the videos
So
for the
maybe
experimentation.
you are using video in your research publications, maybe.
I was thinking about it.
Definitely, you can use AI and you can just cite it. You can just write it. The video was
Okay.
created and it was using this AI. You
By
just
this
cite it.
AI.
So you cite it. Yes.
Okay, okay, sir.
I'll show you.
Okay, thank you, sir.
No, sir, I just wanted to add something to this AI issue. Is like if you're planning an experiment and you need some kind of a script or a vignette study, you can definitely take help from an AI, but publishing it without giving it due credit, and also without any kind of expert validity using that matter directly into your experiment will lead to a clear rejection. That is very obvious.
Yeah. Thank you, Ayushi. I would request
Okay,
all of
okay.
you to
Thank you.
add to everybody's question. I don't know everything under the sky. I might not know everything, so
No,
I'm happy
this
when
is
you display
yeah.
this citizenship behavior, helping others. Thank you, Ayushi. Yes, Nikhil, go ahead. Yes.
No, this is a good point. So I'll also give a real example. There is a paper, I'm forgetting the name, Love in Las Vegas, something where they are manipulating and showing how this particular movie clip is used to induce fear or whatever. Now, typically, suppose you go to AI and say, give me a video clip to induce fear or do something. Now, how do you know that actually fear was only induced? We don't know. So until you either do pilots or, like she said, there are some experts who tell, or it is based on an earlier research which is well established. Sometimes using cues to manipulate or induce something may not be tested, and so it gets rejected. And that actually adds to Mansi's point. It looks from the outside that experimental design is quick, but I have a friend who has published in A Star, I think 2019 to 24, 5 years. Of course, it's A Star, but what happens is, unlike a correlational study, experimental can go very wrong, because if a reviewer gives you a major review, you have to conduct the experiment all over again. and sometimes recruiting or getting people is very difficult. So actually the literature review and the designing has to be super strong, and identification of covariates, as Arunji was saying, and then we actually do it with some pilots. So if it's planned well, data collection is faster, analysis is faster, but yeah, the designing takes time, I guess.
Thank you, Nikhil. Thank you. I appreciate the citizenship behavior of participants. Anybody? Okay.
I have one more question very quickly. It is told these days that you to register your experiment in advance if you want to publish in good journals. Any idea where to register?
Yeah. It's a valid point. There are places where it has to be registered, but I'm not aware of it. I heard this discussion.
No problem.
I heard this discussion. There are you please check it out, because now it is mandatory that if you are doing experiments, it's better to register, because tomorrow somebody might raise a concern that you have not registered it, and there are journals where you have not registered it. They might reject your paper upfront. It can so happen, but I'm not aware of it, and I'm just shooting the arrow in the dark.
Because one journal where I had sent a paper, they not only asked registration, they also want you to share all the data. And either they consent or the link where the data resides. So because they want to check whether you have not manipulated it and the sample size you said and what you got is the same, etc., etc. So I was wondering where to register. Maybe I'll check out, and if I come to know,
check it out, because there are a couple of and there are I heard this discussion somewhere in the month of Feb, again talking to all these senior statisticians, and they were saying that yes, experiment needs to be registered, otherwise it goes invalid. But when I track these papers, in particularly the journal I'm talking about, there nobody's talking about registrations and all, but maybe in the submission stage they might ask for some documents. When you're uploading your paper, they might ask for some documents, so it's better to check it out. But I'm not aware of it, but as such, but it's better to register.
Okay, thank you.
We'll take one more questions and then we'll wind up the session officially, and tomorrow we'll meet at 6 o'clock and we'll see 2 case studies. Okay, any other question from your side? Okay, so officially let's finish this session, and tomorrow we'll meet again at 6 o'clock. These 2 videos I'll upload on my YouTube channel. I'll send you the link, so it will take some time for me to upload it, and I'll definitely send you. And it was really so great to have wonderful participation from all the participants. It's so great and so nice and so lively interactions. I expect these interactions to happen in coming times. Have a great day.
Thank you, sir.
Thank you, sir.
Thank you, sir.